Although most motor-to-pump alignment training programs devote a section to identifying and correcting for soft foot, very few highlight an even more complex and troublesome problem, angular soft foot. In this training video, we are going to illustrate what occurs when angular soft foot goes uncorrected and how Precision Brand's soft shoe shim can quickly eliminate the problem. As you can see, we have mounted a laser pointer to a short steel shaft. As I turn it on, the red dot shows up against the white background. I will insert the shaft into the brackets of our gizmo, which has been designed to show what kinds of stresses are created in a motor that has angular soft foot. Typically, the first thing that needs to be done is to number each of the 4 feet. Foot 1, 2, 3, and 4. Ideally, each foot should be flat to the base and when loosened will rise straight up to show a parallel gap. In this case, however, we have purposely machined foot number 1 to be on an angle. First, I will tighten the good foot, foot number 2, and then the one with the angularity problem, foot number 1. This will make the toe pull down as it is tightened. Next, I'll mark a reference point at where the laser is aiming. Now what I want to show is the type of stresses that are created within the motor housing. And in order to do that, I'm going to have to loosen foot number 2. Watch the laser jump to the left as the good foot is pulled toward foot number 1. What's most important to note is that when I retighten the foot, the laser does not come back to its original position. What this is telling you is that the front of this motor has physically walked to one side and foot number 2 is now sitting at a different position. Besides creating excessive stress to the shaft and bearings, you have also lost any kind of repeatability you will need to properly perform an alignment. What you will need to identify is if the gap is flat or if it is irregular, and to do this you will need feeler gauges. As you can see, this 5/1000 gauge will fit under the outside corners but won't fit under the inside one. And this 9/1000 will only fit at the far outside corner. What this is telling us is that the foot is bent and will be pulled down into position against the base by tightening the hold down bolt. What you are not going to visually see is the internal twisting this will cause within the motor housing. This is the likely cause of ever having chased your tail during an alignment. Now here's a simple solution to correct for what is normally a very difficult problem. These are soft shoe, a conformable slotted shim that has cold flow and set properties which will take the shape of whatever you put it against. Soft shoe are used in conjunction with your stainless steel shims as the outside of your shim pack to replace the shim thickness you already had under the foot. Install the shim pack the same way you normally would. However, since the soft shoe are meant to be compressed, they should be a little tight and may need to be worked into place. As you can see, the gap that was on the toe has already been eliminated. Now, we'll tighten the bolts in the same pattern as we did before, trying to be as consistent as possible with the bolt torques. You'll see the soft shoe side squeeze a little more than the other. Let's reset the dot. Now watch as foot number 2 is loosened. The shaft moves, but only slightly. What you are seeing is the soft shoe trying to return to its original shape. Here's where the real test is. When the foot is retightened, watch as the dot comes back to where it originally started. There's the repeatability you need while performing an alignment. Soft shoe allows the foot to sit how it wants to sit. So when foot number 2 is released, it doesn't get pulled over, but rises straight up. Then, when retightened, it goes back to the same position. If the angular soft foot goes uncorrected, it will pull on the motor housing, causing it to twist and put undue strain across the entire motor. With soft shoe, you eliminate this.